Okay, hey kids, so it's Miss Talent. So I wanted to go over a few ways to stay organized. I know that there's two paths you can be down. Right now you either have the packet in front of you, so you have it all in your science folder, or you're doing it all digitally, which is a new ball game. And so I wanted to show you how to make this folder right here, if you weren't sure. So what you'll do is you'll go to your file up in the corner and you'll make a new folder, and I want you to make it, call it science, and then I want you to store everything in there, and it won't let me call it that because it's already right there, but I want you to make sure you have it in there, all your unit packets, everything that you do, I want you to save it in there, and then when we're back together, we'll make sure it's all in one place and it's not hard to find on your computer. Make sure you label your things such as ringtone, unit packet, things like that. So try to stay organized. I know it's hard to. We have a lot going on, a lot of messages on Canvas, a lot of modules on Canvas. And so this way, when you download it, it will all be in this folder and we can find it when we are back together. If you're unable to find the things on Canvas, it's because you're not clicking modules or home. So everything is on Canvas that was in the hard packet. You can either type your unit packet or you can turn it in hard copy. So just make sure you're keeping track of whichever one you're doing, but everyone has the exact same things offered to them. So just make sure you can locate the Canvas modules. If you're not able to, I want you to message me, or if you're not able to get on YouTube, also message me through Canvas or Remind. So today we're going to go over the end of our notes for this unit. So we're going to always do like a little two section. It's easier to upload to YouTube. So I'm going to open my notes. And we're going to first review what we did the last video. So remember that loudness has to do with how soft or how loud a sound is. And so a soft sound is going to have a small amplitude, a smaller short wave, and a loud sound is going to have a tall wave, such as this. And then pitch has to do with how frequent something's happening, so how often. So a high pitch is multiple, and a low pitch is more spread out. Sounds always travel in waves. We have to have particles for sound waves to occur. So in a vacuum, there are no particles. So there will be no sound in a vacuum. And that's truly why there's no sound in a vacuum, is because there's no particles for the sound to actually bounce off of to create the wave. So sounds actually can travel better in solids, because think about the particles are closer together, and then actually it then spreads out through liquids and gases a little bit more because they're not as easy to spread apart or bounce off of. When you actually make your ringtone next week, you're going to be using GarageBand, and you actually can see the oscilloscope. I always mispronounce it, y'all know me. But it's actually how you would see a wave on a screen. And so, for example, a straight line is going to be dead silence. So this would be like a vacuum. Nothing's happening. A quiet sound, remember the amplitude is smaller, so it's going to look like a tiny wave. A loud sound is going to have higher waves. A high pitch is multiple together, and a low pitch is a little bit farther apart. And this is another little chart to help you with what you learned yesterday or the day before. Okay, we can hear, as humans, we can hear sounds above, we can only hear sounds between 20 hertz to 20,000 hertz. Anything above 20,000 hertz is called an ultrasound, and we are unable to hear that. Now, there might be other mammals on Earth that can hear these things, but we as humans are unable to hear them. So how do we hear sounds? And that's through our actual ear canal, and it's called an auditory canal. And so you have your ear, the outer ear, that actually creates almost like a cone to accept the sound waves. And the sound waves then travel through the auditory canal into the eardrum. The eardrum vibrates when the sound hits, and the vibrate makes the little bones in your ears actually move, and that's called the cochlea. Okay, and the cochlea and the little bones are able to vibrate to then send your brain the messages that you're hearing. And so I know that some of you are really artistic, so you're going to be able to draw this really easily, but as long as you know the order and you write this order right down here on your notes, you'll be just fine. But you do need to know the order that it enters your ear and how it works. Okay? And so now what we're going to do is we're going to now go over and practice some of these things. And so I'm going to move on to my PowerPoint, and I want you to try to answer these before I do as practice, because this would be similar to an assessment. So first, let's look at it. It's either A or B. So the loudest sound. I'm going to give you a minute to try to figure it out. Use your notes. Right. The loudest sound is A because it's a taller wave. Okay, and that has to do with amplitude. Which one do you think has the highest pitch? So it would be A. So I know it kind of is deceiving. There's 3 waves on top and bottom, but this is a shorter time period, so it would be A. It's the highest pitch, more frequent in a shorter amount of time. Which one is the quietest sound? And that would be B. So smaller amplitude gives you the softer or quietest sound. Which one is the lowest pitch? Remember, you can use your notes to check. This one's kind of hard. So it would be B. The lowest pitch is B. So it is going to be more stretched out and so not as frequent, so it's going to have a lower pitch. All right, which one is the loudest sound? So we're talking about amplitude. That would be A. Okay, it's because it's taller. So you could actually say A is a loud, high pitch sound. So you can combine them two because it is very frequent and it has a high amplitude. Okay, which one is the highest pitch? So think about the time, the amount of time. That would be A. A has the highest pitch because in a shorter amount of time it went through 3 waves. All right, so let's review a little bit more. So we have our sound waves, which honestly are traveled through vibrations that compress or refracts, and it causes the actual waves to occur. And one way you can look at this is on your Google Sound game, and I can pull that up in just a minute. You'll be able to actually see them, so I might show you how to use that. And then remember, it goes from the outer ear into the ear canal, and then it vibrates the eardrum and the cochlea and the tiny bones, and then sends it through the nerve. Okay, and once again, we can only hear from 20 to 20,000 hertz. So right now, I'm going to take a few minutes just to show you Canvas. Okay, so I'm going to pull up Canvas very quickly. And each class is the same, so I'm not going to worry too much. So I'm just going to click on first period. And here is all your things. Now you may not see it this way, and if you don't, you just go down to modules, and if you click modules, it will send you to the exact same thing. Okay, and I will upload this video right in here. You have your notes, your textbook, you have your welcome video from me, you have your Quizlet, your unit packet, you have your ringtone project, which I'll have another video over the weekend about how to use GarageBand if you're not sure how to. You have a sound gizmo to help you practice, and then you have this Google Sound Lab, which is really cool. So when you get on it, you can either leave it in this, or I'm one of those people that like an extra tab. And so I'm going to show you how to do it. So you actually can play the instrument, which is a piano or a keyboard, okay? And then when you actually zoom in, these are the air particles, the blue, and you zoom in, and now you're going to get this red line. Why is it straight? Well, it's straight because I'm not playing, so it is silent. But as I play, and I play different instruments, different keys, you'll see the actual sound waves occur. And so you can actually play around with it and see how you end up with it. So that's a really cool way to see the different pitch. Remember, pitch is going to be a different key, and loudness is probably going to be which key are you typing on the black or are you typing on the white. I believe it's how you change it, or you may change it honestly with the foot pedals on a piano, but I'm not 100% sure. If you know, please share on Canvas. If you're a good pianist, I would love to know, because I do know instruments, but not all of them, so I'd love for you to share. This concludes all your notes, going over your notes, so make sure you have your notes in your journal. Make sure you work through your entire unit packet, and then I'll be back later this week about GarageBand and your ringtone project. I look forward to talking to you soon. Make sure you message us on Canvas or Remind with any questions you need. I'm always here for you all. Miss you all and see you soon.